Hey guys, let's take a look at some general pipe sizing considerations. So I've listed in the outline for this particular module on gas pipe sizing, I've listed the general pipe sizing consideration. There's a total of 5 factors that I've identified. So let's hit up on each one of these. So when we determine pipe sizing, one of the first things we got to take a look at is we need to take a look at what is going to be the allowable pressure drop that I'm going to use when I do my sizing from the point of delivery to that appliance. So we've got to figure out what that pressure is to the appliance or from the point of delivery. And then the whole goal of this is going to be we cannot allow the gas pressure to ever fall below the minimum inlet gas pressure to that appliance of what it needs as the minimum. So let's take a look at the typical install. So if I were to look at my example here and I've got, let's say that I determine that I'm going to use my 7 inches of water column as my pressure going from my meter, and I go all the way into my building, and let's say that this one here needs a minimum of 5 inches of water column. This one needs a minimum of 4.5 inches of water column. Maybe this one needs 6 inches of water column pressure to the inlet, and these are all minimums. And then of course the boiler I'll just put as 5.0 inches of water column. So in this particular case, really my maximum allowed pressure drop in this example would really be 1 inch. I could tolerate 1 inch of water column. Typically, I'm not going to size the system for that. Most of the time, I would say we're going to use a pressure drop that's going to vary to be about 0.5 inches of water column as the allowed pressure drop. But there's times where you're going to use a 1 inch. There's times you'll actually do a 1 psi. There's times where you do a 0.5, and it'll vary. You have to know what is the allowable pressure drop. But the definitive reason and how we choose to determine the pressure drop is based on what do you have for available pressure, and from this point over by the meter, from over at the meter, all the way till I get to my appliances, am I going to have enough pressure? And you have to identify that. The other things would be for example, if I were to install a regulator, or let's say in a 2 psi system, I would have a regulator at every one of these appliances that feeds these appliances, similar to what we're going to do in our lab. Now that would mean then I would be seeing 2 psi at that point, and I would probably be sizing, most likely I might be sizing these systems for so that I get roughly about 1 psi of pressure to that appliance or to this regulator. And then you have to look at those examples as far as, so really in this case, my allowed pressure drop is now going to be a 1 psi drop. And then that would give me 1 psi to that regulator. That's just one example. So we'll take a look at another system here. I'll get rid of that. Get rid of that. Okay, so back to the outline. So obviously figure out what your pressure drop allowed, figure out what your pressure drop allowed would be. Don't ever let that pressure get to whatever you need as the minimum inlet pressure to the next point of reduction. Second thing I want to address is the maximum demand. So the maximum gas demand is something that we're going to look at on our systems. So for example, if this particular application is my job that I'm dealing with, and let's say that my range happens to be, let's say that the range happens to be 50,000, I'll put 50K. And this one here happens to be, let's say 40K. And the boiler, let's say, is 100K. And the water here, let's say, is 45K. So in this particular case, I'd be adding up the 100, the 45, the 40, and the 50K. I'd add up all those. So and that would be my total demand. So I would essentially have the 50 and the 40 comes out to 90 plus 45 puts me at 135 plus the 100K. So I'm at 235K. So 235,000 BTUs is what I'd have. So in this example, that would be my max demand. And you may have, that's typically the way it works. So let's take a look at the third thing. So the third thing is the length of the piping and the number of fittings. So what I wanted to outline here a little bit in this little lesson is the length of the pipe and the number of fittings. The standard table assumes that you would have a very minimal amount of fittings by the time you get to the point of delivery. So they are figuring, and this is including all your elbows and your T's and your valves and any fitting that they're using is in that section. So the number of fittings that they're using is actually going to be figured out to be roughly, they're assuming you're only going to use probably at most about 4 elbows or T's. Well, that can really be substantially different. In this example alone, from the time that I left the meter, I've already got an elbow here, an elbow here. I've got this T where I'm doing this reduction. I have a reducing valve here. The unions and that's really nothing. And then you've got this one here. So here I would really have 1, 2 for the T, 3 and 4. I've already got 4 right there just in that one. And that's a very simple system. So it's one of those where I would have to say that I think the table values are probably on the light side in a lot of cases, but generally it doesn't become a problem in most cases. So that's really what they refer to, is so that it's based on that 4, it's based on the 4 T's and 4 elbows, T's, things like that. Things that change the direction of the flow. So that's the main thing. So that's really what they refer to as the length of the piping and the number of fittings on here. So I also wanted to make one other mention in this. And I'm going to go back to this. So why are we concerned about the length and the piping and the fittings and all those types of things? So what is the big deal about that? Well, what you can't have happen in a system is you can't have that happen where all of a sudden you start to supply fuel gas down on this thing, and all of a sudden, hey, we piped it, it's all done, and and all of a sudden this appliance starts to run, and this one, and this one, and this one, and all of a sudden, before you know it, you realize when all those appliances are running, I don't have enough gas pressure going to that appliance. So maybe my gas pressure going to that water heater drops down to about 5 inches of water column. Now, that would be a little bit excessive as the pressure drop, and it's totally fine for the other appliances, but it's not fine for that water heater. So that's basically why we're concerned about the length and the fittings and all those things, is that you're not getting too crazy on it. And if you are going to get crazy, you're going to have a lot of different fittings to get from point A to point B, then you might want to look at other methods. There's a more of an engineered method that you'd have to look at. So that's really what you have to be careful. The last note that I make mention of this is that, when I'm doing service work on applications, the one thing that I want to make sure is that when I do run all those appliances together, that I'm going to have sufficient pressure. And what I might want to, the test that I typically do is what I basically call a dynamic test. And the dynamic test is a test where when I operate the appliances, I see what the pressure is. So it's basically, let's call it pressure seen while in operation is really the way I would probably describe that. The dynamic test is really the one that you want to be looking at. The other test is called the static test, and you rarely will ever see a problem under a static test. It's typically going to be the dynamic test that your issues with gas pressure is going to show up. So just be aware of that. So in this example, if I were to operate all these appliances and I happen to be looking at my fuel gas pressure at this, let's say maybe I took a pressure at the drip leg and I noticed, holy cow, it went down to 5.5 inches or 5 inches. Then I would have known right away under that dynamic test that, hey, there's a problem here. We need to address that. So maybe there's an issue with something you'd have to deal with. So anyways, just thought I'd mention that. The next one I want to get into and I want to address with you guys is called specific gravity of the gas. And essentially all of these, the tables for natural gas assume a specific gravity of 0.6. And directly in the code book, they also point out that if you're going to have a gas that's supplied with a gravity or specific gravity of 0.7 or less, so the 0.7, you do not need to do any corrections on these things. Let me explain a little bit about what that really gets into. So I pulled up in my code book under Annex B, there's a multiplier that they talk about. And what you're doing is, with a multiplier, let's say of 0.6, I'm sorry, the specific gravity of 0.6, they have a multiplier 1.0. That means there's no correction of the tables. If you had a specific gravity of a fuel that would be 0.7, you would see that there would be a 7% reduction in the capacity of that piping section because of the 0.93 that's shown here. And then if you look at the 0.5 specific gravity, you would see that there would be a 10% increase in the capacity of the tables. So what you're doing is you're multiplying the capacities in the tables to meet that requirement. I will not have you guys do that. It's rare that you would need to do that, but I do make you aware of it. That's something to concern yourself with. And the last thing that I'll mention here is the diversity factor. And the diversity factor is one that I'll consider when I'm dealing with appliances that are really never ever going to run in an application. So rarely do I take that into consideration. So it might be a situation where maybe a customer had a pool heater and they will never ever run that pool heater when they're going to use maybe a fireplace, or they're going to use a boiler, or they're going to do something like that. So that's the only time that I would figure the diversity factor. But of all those five, of the 5 factors, the allowable pressure drop, big one. The max gas demand, that's another big one. The length of the piping and the fittings are less of a deal, but it's something you have to consider. My specific gravity and my diversity factor, if that applies, are the things that you have to do. So those are my 5 general pipe sizing considerations.